This is the Angstrom system, which is a 4-source thermal evaporator. The actual vacuum chamber itself is right here on top of this unit, and it can be accessed from either the front or the rear. The front door itself is inside of this glove box, which is used to keep substrates in an inert environment when loading and unloading them. For example, when you're doing OLED devices, the actual films themselves must never be exposed to moisture nor oxygen. So they're loaded through the front door here and then unloaded and processed right inside the glove box. However, for basic optical devices, we don't need an inert environment, so the glove box goes unused for most optical devices, and instead we use the rear door to load and unload the chamber. Opening the chamber, we'll have a peek inside. We see 4 thermal sources, which are basically large pieces of resistance wire, and by passing an electrical current through them, they get very hot and evaporate the material. There's also a shutter on top to start and stop the deposition, which blocks the flux from these sources from hitting the substrates located on this substrate deck right here. In addition to this, you have to monitor your deposition. That's done by 2 crystals. There's a crystal monitor here and a crystal monitor here. This one does these 2 sources, this one does these 2 sources. That allows you to turn on 2 sources at the same time and co-deposit, although we really don't do much of that in this lab. In addition, to enhance the uniformity of the deposits that we're going to be making, the actual substrate holder itself rotates during deposition to ensure a nice even flux all the way across. You'll also notice on the door here that there's a window provided, and that allows you to view the deposition as it occurs. However, direct viewing of the actual sources is not possible. They've mounted it such that you can't actually see the source. This way the window doesn't get cloudy and dirty as you actually deposit. You can, however, see the substrates there. It's actually fairly useful, this window, especially when you're programming the unit itself, to determine which one of the 4 sources is actually lit. So you can look through it and say, it's that one over there, or it's this one over here. Sources are resistive and are heated by passing a large electrical current through them. They can be in the form of a boat, or in this case, stranded tungsten wire. This particular source is used for heating aluminum, and so small horseshoes of aluminum wire are hung onto the actual filament to evaporate them. When the wire heats, the aluminum melts and eventually evaporates. Sources are also shielded, as you see here. It prevents material from one source from being deposited onto a different source and contaminating it. So, for example, after evaporating aluminum, you won't, when you turn on this source, evaporate aluminum that was deposited right onto that source. When the sources are loaded and the glass blank substrates are installed onto the deck up on top, the door can be closed and deposition can be started. For the basic deposition we're going to do today, the sources are already loaded. In the back we have aluminum. In the front we have cryolite, a white powder located in that basket type filament. And on the substrate deck I have 2 glass substrates onto which the devices are going to be built. I simply install this substrate holder and we're ready to go. Deposition begins with pumping the chamber down to high vacuum. Simply start the pumps via the turbomolecular pump controller, which will sequence the pumps and ramp them up to operating speed. The roughing pump is now started, and the controller will slowly ramp the turbomolecular pump up safely to its operating speed. operation takes approximately 25 minutes. As pump down continues, you can monitor the pressure in the chamber using the turbomolecular pump controller. If the pressure is not displayed on the controller, simply press the measures button to toggle between all of the functions. And there's pressure. We'll wait for a few more minutes until it gets down to the base pressure that we need before we can start our deposition. With the chamber finally at high vacuum, deposition can begin. The entire process is controlled from the Infocon deposition controller, which selects the source, preconditions it by ramping and soaking it, opens the shutter, controls the deposition rate, and then closes the shutter when done. So a lot of the work involved in deposition is programming this controller, which we'll address a little bit later in this video. You have to define a film first, and these are then incorporated into a process. Now in this case, the process is already there. It's called MDM filter, and it's already been designed for us. The device is an interference filter, and it consists of 3 layers: an aluminum layer 100 angstroms thick, a layer of cryolite a half an optical wavelength thick, so in this case 1800 angstroms, and finally another layer of aluminum 100 angstroms thick. We begin on the process menu to take a look at that process. So we scroll down and you can see a whole bunch of processes. The one we're looking for is MDM cryolite, so I'll select that process. You can see here the 3 layers it consists of: the aluminum, the cryolite, and aluminum. The S1 and P2 refer to the source and the pocket where that particular source is located. So both of these are located on source number 1, that's on the left side of the chamber if you're looking from the rear. Pocket 1 is the front and pocket 2 is the rear. This is the aluminum layer, and if I select that layer, we're depositing it at a rate of 2.5 angstroms per second. The final thickness of that layer is 0.1 kilo angstroms, or 100 angstroms thick. If I look at the cryolite, it'll be deposited at a rate of 10 angstroms per second with a final thickness of 1.8 kilo angstroms, or 1800 angstroms, which is 1/2 of an optical wave thick in the visible spectrum. This is a dielectric, and it has an end value of about 1.33. And finally, we have another layer of aluminum identical to the first layer. So these 3 layers together form the process called MDM cryolite, and that's what we'll be making today. If I go to the main screen, this is the deposition screen, and I'm ready to go. Notice at the top it says MDM cryolite, layer 1 of 3. It's important that it displays the name of the actual process you'll be using. At the bottom, it displays the rate, the total thickness, and the power that's applied to that particular source. In this case, we'll let the deposition controller do all of the work for us. With the base pressure achieved, we're ready to start our deposition. If it's not already selected for you, go to the process menu, highlight the actual process you want, in this case MDM cryolite, and ensure the process is displayed up here. Press the start button, and in this particular case, each of those 3 layers is set for manual start. So I'm going to put the system on fully automatic. However, each layer I'll have to start myself. I can set these to go fully automatically. It's just the way I set this one up for this demonstration. Let's start the first layer. This is our aluminum layer, of course. And you'll notice on the bottom display, it's showing you power versus time. This is the ramp. And you can see the power slowly ramping up. What we're doing now is heating up the filament, which drives off gases. The other thing we're going to do is heat it up enough to melt the aluminum onto the filament. I programmed the ramp to go to a 15% of full power. And this is where I'm going to soak for 1 minute. This drives off the gases. And you'll notice over here the rate. It's about 0.31 angstroms. Now we're not actually depositing anything yet. The shutter right now is closed. However, we're depositing a little bit of aluminum onto the bottom of the shutter. The system's ready now to open the shutter. It's ramping up now the temperature of the filament in order to get the deposition rate to 2.5 angstroms per second, which is our target. Deposition is now occurring. It's opened the shutter for us, and now we're depositing aluminum onto our glass substrate. The rate is right here, and it's close to our target rate of 2.5, and that's the total thickness of the layer that we're going to grow. Power is controlled fully automatically using a PID control loop internal to the deposition controller. Notice how the rate is very, very stable during deposition. Now our target thickness was 100 angstroms, and there goes the shutter. It's now closed the shutter down, and it's ramping the source down for us. You don't want to shut the filament off too quickly, because you run the risk then of a thermal fracture of the filament. The power is now ramped down to 0%, and we're done with that layer. Once again, the start and stop shows up. Notice it's incremented to layer number 2. Well, once again, it's a manual start layer, the way I have it set up. Again, I can make it fully automatic, but it isn't right now. So I'm going to start the cryolite layer now. Cryolite is a powder, and being such, it traps a lot of gas. So on this cryolite layer, I have a very, very slow ramp and a very, very long soak. And you'll notice the power coming up very, very slowly. Again, this is to drive off all the trapped gases. We determine these ramps and these soak times basically in this particular material by watching the pressure rise in the chamber as I'm ramping it to ensure it doesn't exceed an acceptable value. Now during this ramping time, which takes a few minutes in this case, you'll notice that the pressure has come up quite a bit. In fact, it's actually above what's considered the acceptable pressure in order to do a deposition on the system. So I've programmed in a soak, which will now hold the power at a fairly moderately low rate of about 18%, and this will allow the material to degas over the next few minutes before we actually ramp it up for the actual deposition to occur. Now during the past few minutes, as we were soaking the material at a very low power, it was degassing, and the pressure in the chamber is falling once again to an acceptable point. For this particular material, I've programmed in a second ramp and a second soak to bring the material very close to the point where it's going to deposit. You'll notice the power is now increasing for the second ramp. Now the purpose of this second ramp was to bring the material very close to the point where you're going to deposit. So experimentally, I had determined earlier a power of 26% was about right, and the deposition rate is just under 1 angstrom per second. So we're not losing much material, but we're very, very close to starting our deposition. And in a few moments, the controller will take care of that for us. The controller is now ramping up the power to bring the target rate to 10 angstroms per second. And having achieved that rate, the shutter will then open. And there we go. We're now depositing. We have a total thickness of 1800 angstroms. So this deposition is going to take a while, about 3 minutes to complete. We want to keep the rate low for this particular material to avoid splattering. Cryolite has a habit of spitting little pieces of material up at your substrate when you go for too high a rate. Notice the rate control. The system itself is very good at keeping the rate very, very constant. With the deposition complete of the cryolite layer, the system goes for a rather long ramp down. This is to allow the material to cool and stop depositing. Remember that the shutter is closed right now, but the material itself stays hot for quite a while. So on this particular material, we have a very long, slow ramp to shut it down to allow it to cool gradually and stop depositing. If we were to switch to the other layer too quickly, we would probably mix aluminum and cryolite together, which is not a good thing. When the cryolite is done and it's all cooled off, it switches to the third layer again, and once again waits for my intervention to start the final aluminum layer. This layer is identical to the first layer, so once again we'll have a ramp and we'll have a soak period before the deposition actually begins. It'll then deposit 100 angstroms of aluminum and we'll be done our device. And once again, with the ramp and the soak complete for aluminum, the controller brings the power of the filament up to get the rate to 2.5 angstroms per second, which we specified in the process. And when that rate's been achieved, it'll open the shutter for us and start to deposit 100 angstroms of aluminum. And the deposition begins. It zeroed out the thickness for us, and it's depositing the aluminum. Having achieved our final thickness, the shutter closes, and the power ramps down to 0 again. The device is now complete. Now the chamber is still at high vacuum, and so we have to vent it to bring it back to atmosphere before we could possibly open the doors. Select Start, Stop, and it'll stop the pump. And the pressure will gradually come back to atmosphere. This takes about 4 minutes. And now let's see how our device turned out. Of course, the substrate holder is a pretty color because whatever you deposited onto the glass substrates, you also deposited onto the substrate holder. So the entire chamber itself has been cover coated with your coating. And if I remove one of these, we should be able to see pretty colors through it. And here's the device that we fabricated. Looking through the device at the room lights, you'll notice the color changes as you change the angle of the actual device itself. It's an interference filter, so of course you're changing the optical path within it. The source you are looking at is on source number 2, pocket number 1, at the far right hand of the chamber. It will be the one that we're using for this deposition. Notice that the aluminum horseshoes are already installed onto this source. However, the source right now is not calibrated in terms of we don't really know its parameters. We're not sure how fast we should ramp it. We're not sure how long we should soak it. We'll determine these experimentally from the front panel. Now I'm going to run through the process of programming the Infocon controller on the Angstrom system for a whole new film. So I'll begin by creating a film in the system. The system itself is currently pumping down because I'm going to need it to get some experimental parameters for what we're about to do. However, nothing stops me from pre-programming the controller while I'm waiting. So the first thing I have to do is create a film itself. In this example, I'm going to create an aluminum film on pocket 2, source number 2 within the chamber. So I go to Next menu, and I go to the film menu. There's already a bunch of films that are predefined, including the ones that I used for that cryolite filter. What I'm going to do is take an existing film and copy it to the new film and then make modifications to it. It's usually the easiest way to do it. So I'm going to take this film over here, which is on source 2, pocket 1. I'm going to copy it, and then I'm going to paste it into a new spot. So there it is right there. Now I don't want two of them with the same name, so I'm going to edit the name, and I will delete the old characters. And I'm going to call this one Test. T, and then small letters E, S, T, and save. So I now have a film called Test. If I edit that, The P, the I, and the D terms are already predefined from the previous film. Let's assume they're correct. The tooling factor as well is another one that I'm going to assume is correct from the previous film. Now the pocket on this particular source is pocket number 1. Make sure this is correct. And make sure the material itself is correct for what I'm going to be using. It's aluminum in this case. Now I can select a variety of materials which are already predefined, or I can predefine my own. But aluminum is a pretty common one, so I'll use that one. That automatically defines my density and the Z factor which are necessary. Again, in theory I can change them. Why would I? For aluminum, those are the two numbers. So I've now defined a new film called aluminum on pocket number 1, and all the factors are already defined for it. One of the other parameters you have to define for a film is something called the film conditions. It's the conditions under which you actually deposit the film. Leave this alone for now. We're going to have to determine these parameters experimentally by actually doing a deposition, and then we'll come back to this menu later and finish it off. Because right now, let's assume we don't know these parameters. So I'll go back to the previous menu and then back to the main menu. Whoops, sorry, the main film menu. And of course, there's our material called test. So I've defined a film called test. The next step is to define the process. So, step 2, from the main menu, go to the process menu and define a new process. Once again, you'll find a bunch of processes already on here. I'm going to create a new one. I'm going to edit the name because process 21 doesn't mean a lot to me. And I'm going to call it video, since I'm doing this as an example for this video. So there's V, and make it fancy, I, D, E, O, and save. So there's my video process. Let's go into that process now. Don't worry about the alarm right now for logic statements. That's because I haven't actually defined the process properly. I'll edit this process. So now I have to put films into the process. I'll insert a new film. I will select it off the list, and it must appear on this list. So there's test right there. And I insert normal. So there's my first layer in this process called test. I can now edit this layer. I have to specify an initial rate. So I'm going to push this, and I'm going to specify my initial rate as being, it's aluminum, so let's say 2.5. That's a good number to use for thin aluminum coatings. The final thickness is something else I have to specify. Even if I'm going to do a manual process, you still have to specify this. If you don't specify this and you leave it as 0, the machine will always think you're done with this process. So I'm going to put 100 kilo angstroms in there. Done. Time set points and all of these others, I'm not going to bother defining. Now I do have to define a sensor. I know that everything on the right-hand side of the chamber, when you're looking from the rear of the chamber, everything on the right-hand side is on sensor number 2. So I'm going to turn on that sensor. The other thing I have to specify is the source, and this is important. So the new one is on source number 2. So it's on source 2, I specify that in the process menu. It's using sensor 2, I specify that in the process menu. It's also on pocket number 1, but I've had to specify that already on the other film menu. Everything else should be pretty well defined for me already. And that's it. I now have a process. So the process is deposit 100 angstroms of aluminum at an initial rate of 2.5 angstroms per second. It's on sensor 2, it's on source 2, and of course it's on pocket 1 based on what we got in the film. And that should do it. We're pretty well ready to go. Now, I specified a while back that there's other parameters that you have to put into the film menu. That's what we're going to do first by using manual deposition. Okay, what I want to do now is determine the ramp and the soak that I should use to precondition that filament. So I'm going to start the layer. And it says deposit. So what I'm going to do now is ramp the filament nice and slowly. If I go too fast, I'll crack the filament. Now as I'm doing this, I'm watching the chamber pressure. When I see the chamber pressure start to rise, I'll stop for a while and let it soak in order to degas the filament. I can now see the pressure starting to rise in the chamber. And so it's probably logical that I ramp up to about 20% full power and then let it soak for maybe 30 seconds to a minute in order to allow the gas to come off. And I can see the pressure in the chamber falling rapidly. So the soak is working. Now there is a rate here, which means I'm depositing aluminum onto the bottom of the shutter. I don't want that rate to get too high right now during the soak, or I'll lose all the material on the filament and it'll deposit on the bottom of the shutter and not on the substrate. So I want to keep that rate fairly low, but I want to make sure I'm at least warm enough to get the pressure back down in the chamber. In other words, to burn off all of the gas on that filament. And I can see the pressure in the chamber coming back down fairly rapidly. I'll show you that. There it is, dropping once again. So using the manually controlled deposition, I've now determined that I want a ramp of approximately 1 minute to get to 20% full power. I then want a soak of about 2 minutes, and then I can allow deposition to begin. I'm going to go back into the film menu now and program these parameters back into the actual system. So let's stop the deposition and go into our film. I go back down to my aluminum film right there. Edit film conditions. If you only have a single ramp, you always put it as ramp number 2. So I want to go up to 20%. I want to take 1 minute to ramp to that 20%. And I want a soak time of about 2 minutes to allow the material to fully outgas. I don't need a feed time at all. That was something I inherited from the old film that I copied. So I might as well set them all to 0. And finally, the ramp time, the idle power ramp time, is how long it takes to get back down to 0. So I want it to go back down to 0, and I want it to take about 30 seconds to get there to allow the filament to cool off fairly slowly. And that's it. I've now defined the film fully. So now, if I go into the film menu, and I go down to that film I defined, it's complete and it's ready to be used in a process. Not only are all the standard things defined, like the material, the pocket, and the PID parameters for deposition, but I've also now put in ramp times, and soak times, and idle times to allow that film to be used. So now I can use it in any process and do it fully automatically. So back to my process now, called video. I'm going to set this to be fully automatic now. And that's it. So here's the final run on the process that we made called video. It only consists of a single layer. I select it and ensure it says video right up there, or whatever your layer happens to be called. Start the layer, stand back, and let it do its thing. So now, let's try our process completely automatically. In order to do this, we first put the system on fully auto, so it's auto over manual. Make sure the process is listed up there. Start the process, stand back, and let the magic occur. It'll automatically rise, it'll automatically soak, and it'll automatically do the deposition as specified. There's our 1 minute gradual rise, the ramp, which allows the material to outgas. It also allows the aluminum to melt onto the filament. And now the 2 minutes soak. And we're almost done our 2 minute soak. Notice how the pressures come back to a nice low value. So we've achieved high vacuum once again. And the controller will now take over doing the deposit. Once again, it ramps up the filament to achieve the deposition rate that we've specified, which is 2.5 angstroms per second in this case. Now I might point out that this is becoming a blooper reel, because you'll notice that the power is increasing, however the rate is decreasing. I'm going to stop the layer right now. Basically, I ran out of material. I did not put enough on the filament in order to allow it to do this number of depositions. So be careful when you make a deposition like this. Ensure you have enough on that filament to actually carry you through. The problem, of course, here was that I was doing a lot of experimentation on it to determine the rate and the soak, and that used up a lot of material on the filament. At this point, in order to do the process properly, I would have to open the chamber, put more material on the filament, and continue.